In this video here, we're going to be talking about the rules of the power of a power law and the power of a product law. So the power of a power law states that if you have brackets, for example, 3 to the power of, or to the power of 2, all cubed, we can actually just multiply these exponents together to get 3 to the power 6, or we can take the power and distribute it into the brackets to get 6 to the power of 3 multiplied by 4 to the power of 3. So this would be how you would answer the first question when you have to express it as a product of powers. So here's a product of two powers. So be careful what they're asking for. In this situation, it is clearly asking for the product of two powers, so we'll do that. We'll enlarge it a bit. And for example, we'll do b. So 2 to the power, or 2 times 5 to the power of 4. If you were doing this in standard form, I would multiply 2 times 10, or 2 times 5 to get 10, and then I would raise that to the power of 4. However, they want it as a product of two powers, so you're going to distribute the 4 in. I'm going to demonstrate this by showing the arrows, and I'm going to get 2 to the power of 4 multiplied by 5 to the power of 4, and this is a product of powers. I'm not going to simplify that. I'm not going to put that in standard form. Okay, so you'll do that for all of these. Be careful with the brackets. Again, leave those inner brackets. They're important. So anytime you have brackets, I would leave them unless they ask a standard form, then you'll have to get rid of them. The quotient rule is very much the same. You can distribute the power in. So for example, 10 over 3, all to the power of 3, can be written as 10 to the power of 3 over 3 to the power of 3. Again, it's a quotient, which is division, of powers. So you need two powers here. It's not standard form. Okay? We'll erase some of this. Number 8. Write each expression as a product or a quotient of powers. Again, it's a product, which is multiplication, or quotient, which is division, of powers, not standard form. So we'll do one product and we'll do one power. This is going to be, we'll do b, negative 2 times 4 all raised to the power of 5. I'm going to leave the negative out in front, and I'm going to keep the brackets. And I can leave it exactly like this. This is a product of two powers. I'm not going to even touch that negative. If they wanted it to be standard form, I would do the brackets first, and then I would apply the negative afterwards. They don't, so we're just leaving it. And then we can do this one. Negative 7 divided by negative 2, all raised to the power of 2, is going to be, again, I would throw some brackets in here. If I don't put brackets in here, then what happens is, what happens to the negative? All of a sudden this becomes negative 7 squared, which is going to be negative 49. And essentially this is supposed to say negative 7 times negative 7, which is positive 49. So be careful with brackets. If a situation like that, you have a negative and positive sign, I always recommend put brackets in if you have a negative. It just saves you in confusing in the end. Number 6. Again, we'll delete some of this. Number 6 says write as a power. So again, not standard form, but as a power. The rule says when you have a power outside of a power, we can just multiply those together to get 3 to the power of 8. Again, negative 3 to the power of 8. And I'm going to leave the brackets there. I don't want to deal with the negative right now because I don't need standard form. I'm going to put the bracket in there just so that I can save myself confusion later on if they actually eventually want you to put it into standard form. Move this up a bit. Number 7, 2 to the power of 4 all raised to the power of 2, and 2 to the power of 2 all raised to the power of 4. What do you notice? Explain your results. Again, my recommendation is to simplify these. Figure out what this is. Figure out what that is using the rules above, not standard form. Well, you could do standard form, either way. I would use power rules, it makes it simpler. And then just talk about what the results are. Are they the same? Are they different? Why are they the same? Why are they different? Okay? Again, remember, you're demonstrating this. You have to show your understanding of this. Number 9, why is this a negative value? Okay, so when you're doing this, why is it a negative value? What I would recommend is solve it. Is it a negative value, first of all? And if it is a negative value, can you explain it? A hint, the hint is this 2 here. Okay, that's a little bit of the hint. What does that apply to? Does it apply to the negative 5 or does it apply just to the 5? If it applies to the negative 5, you get a different answer than if it applies just to the 5. So think about that. Number 10, simplify each expression, then evaluate it. So here, you're going to simplify, then evaluate. So simplify means you put it as a power. Evaluate means standard form. So we're going to do 2 answers here. So let's do B. Negative 2 multiplied by 4, all raised to the power of 2. Let's simplify it first. We're going to distribute. So this is negative 2 squared times 4 squared. There's my simplified version. Sorry about the 2. Then I'm going to do this to get positive 4 times 16. We can't use the product rule here because the product rule says when the bases are the same, we can add the exponents. The bases aren't the same. We can't do that. So now we're just going to go positive 4 times 16, which is 64, and a positive is a positive 64. Don't need to show the positive, but I like to, just when I'm doing negatives and positives, so to show a positive just to make sure. Again, we can do another one. 8 over 2 all squared. They want you to show an expression, so we're going to simplify the expression. So this is going to be 8 squared divided by 2 squared, which is 64 divided by 4. Oops, 64. Okay, which is going to be 16. And there's your answer. So again, just be careful. You want to do, there's 2 answers to this, and you have to, like always, you're going to be demonstrating your work. Okay, so make sure you're showing your work if you want full marks on this. Number 11, why is the value of negative 2 to the power of 3 all raised to the power of 4 positive, but the value of negative 2 to the power of 3 all raised to the power of 5 negative? So why is one positive and why is one negative? And again, my recommendation is it's going to have to deal with your exponents. Okay, so take a look at them, apply some of the laws, then use your laws of exponent or your laws of integers and try to rationalize out that question. We're going to go to the next page now. So here, what are we looking for on this page? We're looking for, can you find the ability to find errors? Okay, so that's these kind of questions. And we're also looking for, do you have the ability to do both the power rule and the product rule together? Sometimes it's confusing. Again, we're going left to right. Laws of exponents always applies. And then, can you do order of operations? Which again, it's the order of operations up here, and it's order of operations up here as well. So make sure that you're always using order of operations, be it a simple adding question all the way up to second, third year university question. You're always using order of operations. So let's try number 16. These top ones here you're going to just have to work through. But number 16, we will try, for example, we'll try, again, I keep seeming to go with B, so why don't we just do B? We have an addition statement. So the rules say there are no rules for powers and addition, so you're going to go this side and then this side, and then you're going to add them. So let's do this, and again, you'll demonstrate this, you will show all your work, so write it out. None of this will be done in your head. It takes some time to write it out, but not a big deal. I see a 0. We know anything raised to the power of 0 is 1. So right away, that whole bracket is 1. Because it doesn't matter what's in the bracket. It's raised to the power of 0. Get rid of it. And then we'll do this part first. Again, we're going to simplify it first and then evaluate. So we're going to distribute in. We're going to get 3 to the power of 9 divided by 3 to the power of 6. The rule says we can multiply, right? That's the product rule or the power of a power rule. Then we're dividing. So the division rule, the quotient rule says when the bases are the same, we can subtract. We're going to get 3 to the power of 3 plus 1. And this here is going to be your simplification. Like this whole part is your simplification. Then you'll figure out what 3 times 3 times 3 is, which is 27. We're going to add 1 to it. And we should get 28. So on the rest of the questions, you're going to be doing the very same thing. Again, here's the power of a power rule. Here, power of a power rule, you can distribute the 2 in, and then the quotient rule. They're different rules. Remember, this rule here says we can multiply these powers together to get 12. We can distribute the 2 in to get 2 to the power of 8 divided by 2 to the power of 6. Then you have a quotient rule, which means then you subtract the exponent. So don't get mixed up on the rule. There's a lot of rules. Okay, when the power is on the outside of the bracket, we can distribute it in and we're multiplying. When it's together like this, that's the quotient rule, would be subtracting here. So it would be 2 to the power of 6 divided by 2 to the power of 4, which is 2 to the power of 3. Okay, so be just, 2 to the power of 2. And then you can distribute the 3 in. So again, there's a lot of ways you can handle this. Some people will distribute the 3 in first, and some people will do what's inside the brackets first. They're the same answer, so you don't need to worry about that. Just keep in mind on all of these kind of questions, I'll enlarge it here, addition, subtraction, addition, addition, meaning this side gets done before this side. Then we add. This side gets done and then this side. And then we subtract. Be very careful. Okay, because that tricks up a lot of people. And then they get the wrong answer and they don't really know where they went wrong. Keeping in mind there's no rules for adding and subtracting of powers. Okay, so number 17, we're going to simplify it again. We'll just pick one randomly. We'll do, ooh, what a shock. We'll do B. And we'll do this side. And then we're going to subtract the answer to this side. So I'm going to distribute in this 2. And I'm going to rewrite this whole question down here as negative 2 to the power of 6 divided by negative 2 to the power of 4. I'm out of room, so I'm just going to do this, and then you're going to have to show it all. But actually, you know what? I wish I would have done it a little bit better, but that's okay. I can move it over. Okay, minus negative 3 to the power of 6 times negative 3 to the power of 4. Okay, so here's my new question. I'll do this part first. Bases are the same. They're both negative 2. So the rule says when the bases are the same, I can just add, or sorry, we're dividing. I can subtract those. So negative 2 to the power of 2. I'm going to subtract here. We're multiplying. The bases are the same, both negative 3. It means I can add those. 10. And then I'm going to figure out what negative 2 times negative 2 is, positive 4. And I'm going to subtract the answer to what negative 3 times negative 3 times negative 3 dot dot dot, which means 10 more, or do it 10 times. I'm not going to do that. You'll have to. Whatever the answer is to that, you'll be subtracting. So you're going to go positive 4 minus whatever you get from this monster. It's going to be pretty big. Okay? So that's that kind of question. Let's look at number 19. Again, we're combining all this together, so it does get quite confusing. It's understandable that if you're confused. Let's look at C. Okay, we're going to move all this up. So I'll rewrite this question after I've distributed. So I'm going to distribute the 2 in, and then I'm going to distribute this power in, and then rewrite the question. So negative 4 brackets to the power of 6 times negative 4 brackets to the power of 4. I'm going to add 4 to the power of 6 times 4 to the power of 4. Okay? Now, again, adding. We have 4s all the way across the board. However, first of all, the bases are different. We have 4s here and negative 4s here. Different bases, no rules apply. And secondly, we have an addition question. So we're going to do the left side of the addition, then the right side of the addition, and then add them together. So negative 4, the bases are the same. I'm going to put them in brackets, and I'm going to add those together to get 10. I'm going to add, again, positive 4 times positive 4 to the power of 6 times 4 to the power of 4. Bases are the same. I'm going to add those together. Then I'm going to figure out what this is. I'm going to figure out what that is. That's why we have calculators. And then I'm going to add them together. So you're going to go negative 4 times negative 4 times negative 4 times negative 4 times negative 4 10 times. And then whatever that is, you'll be doing it on this side as well. Add them together, and there's your answer. So be cautious. F is funny. Okay, careful with F. For some reason it didn't come over. This is the whole question. So at the end of all of this monster, we add this part too. So just be careful on that one. I don't know why it didn't come over nicely, but it didn't. So hopefully that video helps. If you have any questions, I'll be around to help. Okay, take care.